Hello, it's Dallin and Henry here, and today we'll be teaching you about the tangent function and its graph.
So first off, we're going to define the function of tangent of theta. So another way of writing this would be sine of theta over cosine of theta, which I'm sure you are all familiar with. Sine over cosine. So now we're going to look at the unit circle and some of the values of theta on the unit circle and what the tangent of those values are. So I'm sure you're all sure that on the unit circle, the sine corresponds with the y coordinates and the cosine of theta corresponds with the x coordinates. So some really simple values we're just going to look at this table right here. So first off, when theta is equal to 0, right there, that means that it is right here on the unit circle. And as you can see, the y coordinate of the unit of that point right there is 0. So anything 0 divided by anything is just going to be 0. So the tangent of theta right there is going to be 0. So now we're just going to clean this up a little bit right here. Next value that we are going to look at is pi over 4 on the unit circle. And this is right there. So I'm just going to draw a little triangle right here which shows the x and y coordinates of pi over 4 on the unit circle. And because this is the same thing as a 45-degree angle, the y coordinate is changing the same as the x coordinate. And so as you can see right here, it is labeled that the x and y coordinates on the unit circle of pi over 4 is square root of 2 for the y, square root of 2 over 2 for the y, and because it's y over x, the x coordinate is also square root of 2 over 2. And because it is being divided by the same thing, the tangent of theta at that point is just going to be 1. We're just going to clean this up one more time. Just a moment here. The next value on the unit circle that we will be looking at right here is pi over 2. And as you can see, pi over 2 is located right there on the unit circle. So as you can see clearly on the unit circle, the y coordinate at pi halves is going to be 1, which is right there. So 1 over the x coordinate right here, which is 0. And division by 0 is not possible. So the point at pi halves is going to be undefined.
The next thing that we'll be looking at is tangent as slope. We've already defined sine of theta as y and cosine of theta as x. And if you recall, slope is delta y over delta x. If we come over here to the unit circle, you can see that for any degree of theta, the delta y and the delta x corresponds to sine and cosine. I'm going to clean this up real quick. Recall the tangent of 0, which is this line right here. On the previous page, we already decided that the tangent of 0 is 0. Another way to think about it over here is looking at the slope of this line. The slope of this line is 0 because it is horizontal. Look over here at the graph, you'll see that at 0, tangent crosses the x-axis. It does this as well at pi, 2 pi, negative pi, and negative 2 pi. So at each one of these places that the tangent graph is 0, the slope of the unit circle line will also be 0. If you look on the tangent graph, you'll notice it has many distinct asymptotes. Hopefully if you think about the slope on the unit circle, this will make sense. We'll look at the specific point of pi halves on the unit circle. The slope directly at pi halves is undefined because it is a vertical line. However, as the slope approaches pi halves, you notice that it gets steeper and steeper, getting closer and closer to infinity. This explains why on the graph there is an asymptote at pi halves, because the tangent graph approaches infinity.
So now we're going to talk about the period of the tangent function. So as I'm sure you all know, the period is defined as the amount of time it takes for the function to repeat one cycle. Or an easier way to look at it is how long it takes for it to repeat itself. So as you can see, this function repeats itself over and over and over again. Just a bunch of these guys. And so right here on this particular function of tangent, the period is pi, because that's how long it takes for it to repeat itself again. But the period of the graph can also change if you put a number in front of the theta, such as tangent of 2 theta right here. So the period of tangent of 2 theta would be pi halves. So the graph appears twice as often. And so the general rule for the period of tangent is it is pi over b, because no matter what number you plug in front of the theta, this general rule will always work for the period.
Thank you for watching. Hope you have learned something new about the tangent function today.